If you're replacing your AC unit this year, there's a decision most homeowners don't even know they have to make. And it could be worth thousands of dollars in savings or cost you thousands if you make the wrong decision. And that's why today we're comparing a heat pump versus a standard AC, side by side, part by part, so you know exactly what you're paying for. Let's get into it. So first thing we're gonna start off with is this heat pump, the hard start kit. Now this one actually came with the hard start kit, which is great. A lot of units do not come with hard start kits. They're really great for systems to, when they start up, it gives them that extra oomph. Most manufacturers will tell you you don't need the hard start kit, but it just does cause less wear and tear on your compressor, which is something that we definitely want to look at. In anything we can have less wear on something that's critical, we like to think that that's a pretty good part to have. So these are great to add to your unit if you don't have them. Not all units can have them. Obviously your high efficiencies are not going to be able to have them, but on anything that's a standard AC or a standard heat pump, I would highly suggest it. When you're looking at replacing this or even adding a new one, you're looking at about $340 for the cost. That includes labor, the part, any kind of overhead that we have. Pretty good part to have. I would definitely suggest anybody that doesn't have one on their unit to go ahead and get one put on. It's a lifesaver when it comes to that compressor. So now let's switch over to the AC and see, does it have that part, does it not? And as we can see, it had one on there. Now this is an aftermarket one. By the looks of it, it was something that was added on. Being that these units are from 2004, both of them, it's a very good chance that that compressor might have started wearing and going out to where it was kind of locking up, and this kind of got it by for a couple years. We do that often. But ultimately, just because you have a hard start on your unit doesn't mean that it's something wrong with your compressor. I would highly suggest any brand new unit to have a hard start kit on it. So these are standard parts on a heat pump and an AC unit. So if you're looking at any kind of unit, you're probably going to see these. It's not on every single one. Like I said, it depends on the manufacturer, but highly recommended for all standard AC and heat pumps. Let's go ahead and move on. So now back over here at heat pump, we're looking at a contactor. Now this is a part you're going to find on both units, standard. Unless you're going with high efficiency, you're pretty much going to find a contactor. You can see right here, we got this contactor for this one, but this is for the heat pump. There's going to be no difference in these. The things that you will see different is we have different kind of contactors. One will be called a double pole, one will be called a single pole. There is a little bit different in pricing in that, but not too much. Pretty standard for both of them. They are very important. This is what's going to turn on your unit. You can think of it as a simple switch. When I send 24 volts from my inside to these contactors, it pulls in this contact, and that makes your power able to go through here to your fan motor and to your compressor. So very important. A lot of things we see with these is they do get wore out over time. Just that on and off is going to start wearing out what we call these points, and they like to get pitted and stuff like that. There's reasons they do that, and there are contactors that are better that kind of help prevent that and will last a lot longer. They do cost a little bit more, but I would highly suggest upgrading to any of those contactors. When we're looking at pricing for this, we're going to be looking at about $325. That's pretty standard. It could be a little bit more if there's something special with it, but a standard contactor is going to be about $325. That includes parts, labor, any kind of overhead that we have to tack on, sadly. But that's really all I got to say about this part. So really no difference in these parts. It's going to cost you the same amount. So when it comes down to picking between these units, if you're looking at something that's going to cost more or less, this is a part that's not going to cost you any more. And it is a standard part that does go out. It's very common to go out. Probably about 10 years down the road, you'll probably get suggestions to start replacing this. You could go as long as 5. You know, those are always things that can go, but usually about 10 years is what you get out of these. All right, so next up we got a capacitor. And these are called a dual run capacitor. And the reason they're called dual run capacitors is because they're pretty much 2 capacitors in one. So when you're buying this capacitor, you're not just getting 1, you're getting 2. You can have different things that you might want to just have a capacitor for the fan. That does happen, and so you would just alleviate one of these, and that's stuff we make decisions all the time. But most time, this is a part that you're gonna see replaced often. Usually lasts about 5 years. They can go as long as 10. This is all gonna be based on how hard your system works. There's other factors. If there's any wear and tear to that compressor, it's gonna affect this. If there's any wear and tear to that fan, it's gonna affect this, and so that can knock it out faster. Sometimes it has other variables, but really what kills these is heat. So anytime you're pulling more electrical for the fan or the compressor, it's causing more heat on this. We don't want that. Heat's bad for these. You are looking at, you're gonna have to replace this every once in a while. We do test them, and you can actually see on these, it's actually related on what the actual size is. This one's actually an 85. So that means for the fan, we have 5 microfarads. For the compressor, we have 80. So we wanna make make sure those are right because those are specced for these motors. We don't want to get out of the specs of what the motors call for. So all those definitely need to be right. That's why we need to make sure we are getting the right capacitor for the job. With these, like I said, they're pretty simple parts. They are kind of expensive, but when you're having to come out and drive a truck out there, come into your house, it really does start to add up with all the overhead that we have with it. Like I've told people for years, if you want to go ahead and just bring your unit over to my shop, I'd be happy to diagnose it for free, and we can probably get it a lot cheaper for you. Most people aren't going to disconnect their unit and bring it to me just to look at it. When you're looking at pricing of that, you're looking for a dual one like this, you're looking at about $250 plus. They do vary based on the size. So obviously if we alleviate them between 50 and below and 55 plus. So those are usually how we judge that. Part's pretty simple. We usually have these on our truck. When we use them, you can tell like this one is actually assembled in Mexico. That's kind of interesting for that age. But most of these are made in China, and the China ones are horrible. Every time we put one on, we put American made. Some people will tell you there's no difference, but I can tell you there's a difference between bean oil and synthetic oil is a lot better with heat. So the American ones are made better. Definitely would always suggest buying American when it comes to capacitors. There's other things that it doesn't matter, but this is very important. That's all on this heat pump. Let's go ahead and go over to this AC unit and see what it has and see if there's any difference. So as I said before, this is a pretty standard part. It does have a capacitor. The difference in this one is that it's an actual 60 by 5. So we're obviously using probably the same size fan motor if we looked at it, but the actual compressor is a different size, which we know that because the heat pump is actually a 5-ton and the AC is actually a 4-ton. So that kind of makes sense why we're having a little bit lower of a capacitor. You could still have the higher capacitor for a compressor over on the heat pump because it might use a different compressor that might need a little bit more energy for whatever reason the engineer spec'd whatever they did, and that's above my price grade. So I don't know too much about why they spec some of those things, but that's for an engineer to decide. I just work here. But with that, you're seeing same capacitor. Obviously this one is an American made one. It's been obviously replaced sometime in its life because this is not the original capacitor that would have came with this unit. Now this kind of brings to another side note on this. If you actually look at this one, we have quite a bit of dirt built up, and that's going to definitely cause problems because that's going to cause this unit to get overheated. That's one reason we say maintenance is very important. And one reason that I like these units that I picked is they're pretty identical. Obviously the size is a little bit different, but they're both 2004. There's a couple different design differences, but they are pretty much identical, minus being a heat pump and an AC. But with this, that I also liked is this one, when we tore it out, obviously the homeowner did not take care of it very well. And this one over here, I actually spoke with the homeowner, and you can see he obviously cleaned it out. He talked to me about when he did this, about how he would come out yearly and clean his unit. So it's definitely taken care of better. You can definitely tell a difference, but they're both changed out at the same time. If you look at this one, a lot of these parts are actually original parts compared to this one. Had a new contactor, had a new capacitor. They've had a lot of work that had to keep this one going compared to one that's been maintained and didn't have to have all that stuff replaced. But that's all I have to say about a capacitor. Definitely make sure you do your maintenance. These are parts you're going to have to replace. Even this one, I'm pretty sure that it's been replaced, but it's been replaced a long time ago. That's an old capacitor, whereas this one's a lot newer. So maintenance and keeping these things right is going to keep your unit lasting a lot longer. And this is a defrost board. Now we're coming to a part where we don't have a whole lot of different parts between the heat pump and a standard AC, but this is one we're definitely going to have. Defrost board is exactly what it's for. We're going into a defrost. Obviously this unit is going to run in the winter time and we're going to get below freezing. With that, I'm actually going to get this coil temperature below freezing, so it will start to ice up. Now if you ever get a heat pump and it starts icing up a lot, you really want to have somebody look at it. They can ice up just a nice little layer and then go into defrost. A lot of people are confused about defrost because it does all kinds of different things you're not used to, and so I always like to go over that with homeowners whenever we install or work on a unit that they have never had a heat pump. I like to talk to them about that. So one things I always talk about is defrost. These things are going to go from defrost with this. It'll be in the winter time, and usually what you'll see it happen is the unit will be running and all of a sudden either it will stop or it will switch our reversing valve and go from heating into a cooling mode. And what it's doing is actually just reversing the refrigerant flow and causing this coil to heat up. At that time, they're going to actually have the fan turn off. So one thing you will notice if it's in defrost, the fan will not be running. So if you ever go out in the winter time and you have a heat pump and it's running, but the fan is not, that might be normal. That doesn't mean there's not a problem, but it might be normal. Another things that people see is when it goes in that defrost, it has a chance to make steam, because obviously we have ice on this and we're causing a very hot coil coil so we can get this defrost as fast as possible. When it defrosts like that, it's going to cause steam. Now, this could look like smoke. So anytime you see your unit and it looks like it's smoking, I would definitely go over there, see if your fan's running. If the fan's not running, I would take it that it's in defrost and there's not really a problem that you need to worry about. But if you ever run into a situation where the fan's running and it's smoking, definitely shut off your unit. Definitely call us to come look at it, or any other heat and air company that's qualified to look at those. But with defrost boards, they're pretty common. The things that you're going to run into problems are just like any other control board. Any kind of power surges into it is going to affect it, things like that. So you want to make sure you got surge protection, all those good things to try to protect this board as much as possible. Besides that, they're a pretty standard board. We usually go back with OEM. We do have a couple aftermarket options. We don't usually do that. We like OEM because then we're getting back to factory spec and how the manufacturer wanted this unit to run. But when you're looking at pricing for this, we usually look at about $550 and up. Now that's going to vary because of different things like manufacturers on the price of the part. So that's where a difference is going to come in. We could have a board that's got a lot of technology in it and it's going to cost us $1,000 for the board. So obviously those prices are going to be passed on. Besides that, we don't see too many problems with this, but when we do, it's usually after lightning strikes, stuff like that. If you're getting a heat pump, definitely ask your contractor all the questions you have about that heat pump and how it's going to react different than the AC unit you have now, because there are going to be differences, and there are going to be differences by brand specific too. So you want to make sure you have all the information you have so you're not calling a technician out when you don't need to. Obviously over here you can see we don't have a board in here. There's nothing that we can pull out, no board. So that's one less part failure that you would have, and that's kind of a plus about a AC unit over a heat pump. It's one less part that could fail. All right, next we got your fan motor and your fan blade. Now most of the time your fan blade's not going to have any kind of problems. You can always run into a problem with a fan blade when you obviously get any kind of thing that might cause damage. If you hit it wrong, if it gets out of balance, any of those things can be common things that you can see, but it's not something we run into a whole lot. Where we run into some of the biggest problems with heat pump is these fan blades like to gather ice. And so a lot of times I tell people with these that whenever it starts really raining and getting a chance of freezing rain, you might want to switch your heat pump to emergency heat. If you don't know how to do that, definitely ask your contractor, because there is a difference in some units, but for the most part, usually at your thermostat, you'll have a place to pick emergency heat. So on those days where you're going to get below freezing, freezing rain, even sometimes snow, depending on how it goes. If it's a lot of snow right at freezing, it could melt and then refreeze on that fan blade. What happens there is ice builds up on this fan blade, it kicks on, it not only can throw off the balance of the fan blade, it can actually throw ice onto your coil, and then you're looking at, do you replace your coil? Can it be repaired? Is it going to cause any leaks? So we want to try to avoid that. So switching over to a heat pump, switching it over to an emergency heat is a great way to just not have to have those worries. With that, when we're talking about fans, this is a pretty common fan, just a simple PSC motor. They are getting into more ECM motors on these, so that's going to get a little bit pricing, but for the most part, we're still seeing quite a few PSC motors. These usually have grease in the bearings. They're sealed bearings. We can't add any grease to them. So with that, they start to wear out. And one of the signs that those bearings are going out, you can start to see kind of an oil film on this, anywhere on this motor. So sometimes you see it right here start getting out. And usually what we see is like the top one will go and you'll have some leaking out up there. We see them all the time. They do run if you want to keep them with that. But as it does, it's going to start wobbling more. It's going to start causing other problems. Obviously, it could shut down randomly. So a lot of the times when you see customers that we come out and it just shut off, we don't know why, and then it's running fine when we're there, and then we leave and then it shuts off again. Sometimes that could be a fan motor as a problem. If this fan motor is going out, it's not allowing the heat to escape. We're going to go off on a high pressure switch, which we'll look at that later, but we definitely don't want to go off on that high pressure switch. These actually have to be where they're reset if they're high pressure. That's not good because homeowners don't always know where those reset buttons are, and sometimes they're hidden. Luckily, these are pretty simple. I'm going to show you that later, but with that motor, we want to make sure that motor is doing good, and having it checked once a year is great because we can definitely make sure that it's not over amping. We can check those bearings, make sure they're solid. I mean, if you look at motors, this one right here is let's see, 22 years old, and you actually feel this motor and the bearings feel pretty solid. The motor looks pretty good. This was a well taken care of unit. I can't stress that enough. Even though it looks kind of wore out, this is a good motor. Now obviously I'd have to do a couple more tests, but for the most part I'd be pretty sure that this motor is doing great. Besides that, let's go ahead and look at the AC unit and see what we got going on over there. So here we are, a little bit different style. That's the one thing about the AC to this. They had a little bit different style. This is actually their older cabinet style, to whereas that's their newer cabinet style. Not too much difference. I like both of them. They work really well. Obviously, you can see you can get to electrical without actually having to take the top off to get to everything else. The only thing you have to take the top off for is to get in this fan and cleaning the unit. So that makes it really nice for us as technicians. But this fan motor is pretty much the same thing's going to go. That blade's going to have, not going to really worry about ice built up on it. You can get ice built up on it, but it's not running during that time. You shouldn't really be running this AC when it's 32 degrees outside. Are there people that do? Yes, there are. If you are somebody that's going to be running your AC in the winter time, we definitely need to have a conversation with your technicians to see how they like to alleviate that problem. One thing we do is we like to put low ambient kits on anybody that's going to run low. It does pretty well. I will say a low ambient kit's not a complete fix. Obviously, you start getting down to freezing, and I can't do too much once we get down there. But if you're going to run in low ambient temperatures, we need to look at something like that to kind of keep the unit running a lot more efficient. But when we're talking about prices with obviously the heat pump or with this standard AC unit, we're looking at the same prices for motors. Motors are going to be about $825. Could be a little bit more. Obviously, if we have those ECM motors, probably going to be a little bit more because I'm going to have to get those from manufacturers. And then when we look at the fan blade, you're looking at about $325 plus. Obviously, that's something we're going to definitely have to look at what we need manufacturer size wise, but they're going to be roughly about that price. So when talking about the fan motors, this brings up another conversation. One thing you got to realize when you're doing with heat pump, you are running that heat pump more during the year. You're not running it quite twice as much during the year as much because you're going to be picking up some other things. You're obviously going to have some emergency heat kick on sometimes and stuff like that. So those are always factors, but you're going to run it a lot more. So with that, you're going to have a lot more wear and tear. So that's something to always consider when you're going with a heat pump. You will have parts that will wear out faster because you will be using it more. But in the same sense to whereas you have an indoor unit and you could be using like electric heat with a heat pump, which is the most efficient. A heat pump's way more efficient than that electric heat. And that's the way you really want to go, is to have that efficiency. It would pay for itself. And you're going to wear out those parts one way or another. So even the same thing as a standard AC, let's say you had a gas furnace, you're going to be wearing out other parts. So there's always a consideration. But realize that you will probably have to replace a few more parts on this regularly that they both share because fans are going to run longer, all those kind of stuff. But as we said before, you look at this unit compared to that unit, this unit is obviously in a lot better condition. And we can actually look at this unit over here and we can see that this actual fan motor has been changed out. It is not the factory fan motor that we had before. So those are considerations. Maintenance is key. You want to make your parts last longer. Maintenance is going to be the regular that you need. Whether it be you doing it yourself, every homeowner can do their own maintenance. It's tedious, it's time consuming. Obviously, you're not going to be as fast as what my guys are because we've been doing this for a long time and that's what they're trained to do. But it's something you can do on your own and you can get good at it. And just like this homeowner, keep a unit looking really great with a factory motor, all the good stuff that you would want. So definitely consider that, but let's go ahead and move on. All right, so now we're going to be talking about the actual coil, the condensing coil. Actually, out here on this heat pump, this is not called a condensing coil. This kind of does both. We just call it the outdoor coil. It will condense whenever it's in the cooling mode, and then it will be actually the evaporator whenever it's in the heating mode. So with that being said, there's not too much difference on coils. They're all kind of the same. You do have a couple different variants, whether it's a spine coil or a micro channel coil, or your just standard copper coil like this. Love these coils. They're really great, but the things that you can run into is obviously any kind of damage on it. Obviously these fins are folded. These are not that bad for what they are, but any kind of less air being able to go across there is going to allow less heat to be dissipated out of that unit. And we want to make sure all the heat we can dissipates out it. So things like that, you could actually kind of comb those out. Those aren't too bad. Obviously, if you get a really bad gash, it might be bad enough gash that you can't actually fix it, but you're not really needing to replace that coil. It's just going to knock down your efficiency by a little bit. But when we're talking about that, we're talking about, like, let's say we're going from a 60,000 BTU unit to a 59,900 BTU unit. So that's not that much of a BTU. Your efficiency is going to go down. Let's say it costs you a couple dollars more a year because of a gash in your unit. That's not bad. As long as it doesn't get in there where it's causing a leak, you usually are okay. We obviously want to prevent those. So anytime you're working around these units, you want to make sure that you think about what you're doing. If you're weed whacking, you want to make sure you stay away from those coils. Make sure you're not throwing grass on it. With that, even with your line set, we see quite a few with the line set that goes up. Usually you'll have a a wire that runs, and those get hit by weed whackers all the time. You get dogs to chew on them. Another thing, speaking of dogs, you do get, I just had a phone call with a customer yesterday that she had, her dog was actually relieving himself on the coil, and from that it had actually got these fins to erode, and you could actually see the copper, that there was so much erosion. We see some bad. Hers didn't look bad enough that she needed to do anything right now, but we definitely want to keep an eye on it and make sure that dog's not doing that anymore, because it can cost a lot of money. Because when it comes down to pricing for these coils, you're looking at, under warranty, about $2,000 plus. There's some different factors there. Obviously, how much refrigerant we're going to use, because anytime we open up a system, we like to use fresh refrigerant. If you're going to replace it not under warranty, you're looking at $4,000 plus. So that's a pretty hefty bill for just a coil, but it's a lot of labor to get this coil back in there and get it right. So that's where, whenever we start getting into those kind of prices, we need to start looking at what's the difference in actually going for a new system and putting that money into something that's going to last a lot longer than something like this, 22 years old. Are we going to replace a coil here? No. I would highly not suggest doing a coil. Sometimes it's hard to get these coils. I do believe I still can get these, but I would have to definitely search. I wouldn't want it for my house. I would go ahead and look at a new unit at that point, especially with the age. Another thing to talk about this coil that you want to talk, I know I'm repeating it over and over again, maintenance, maintenance, maintenance. This is a very important coil to have maintenance on. If you actually see it, it's actually a double coil. You have two coils put into one. So because you have two layers of coil, you can get a lot more dirt built up. A lot of manufacturers are going for this to reduce the size of the unit. Most people, we used to have those big units we came out with, and people hated them. They went from this little bitty unit, less efficient, to this big massive unit outside, and manufacturers heard a lot about it. So they said, well, we can reduce it down by doing this. It allows for a smaller footprint, and so there's price incentives for them to do it, especially for not having to push that price off onto a homeowner, but it does cause other problems. You definitely want to make sure you're maintaining it regularly. Let's go look at the standard AC coil as opposed to this heat pump coil and see if we can see any kind of differences. Well, I think I found the only difference we have here. It's dirty. Even in these corners, you can see where it's got dirt in between the two coils. That's not a good thing. Once we get coil that's dirty on the inside, we actually have to start looking at taking these apart and separating the coils. And I know that a lot of these do not like to separate easy. So anytime you can save any dirt getting in there, I would highly suggest it. Knowing what kind of a coil you had would be something I would definitely ask my manufacturer. They might look at you like you're crazy. Why would you want to know that as a homeowner? But it's good for your information to know, do you need to pay attention more of how you're doing your maintenance? If it's a split coil like this, two coils in one, you definitely want to make sure that it's maintained once a year. The heat pump, I would say twice a year. And really, I would say even throughout the year, kind of trying to make sure that it's cleaning. What I do, and a lot of people would be against it, is I like to clean my unit from the inside out, give it our once a year cleaning, and then throughout the year as I'm mowing and stuff like that, I usually take my hose and just kind of rinse it down, make sure all that grass that I just mowed is not getting into it and stuff like that. That's going to save your unit and keep it a lot cleaner for a lot longer. That's all I got to say about this part. All right, next up we got a liquid line dryer. This is actually a bi-flow liquid line dryer, something you're going to see on most heat pumps that allows the refrigerant to flow both ways. We definitely want to make sure we're flowing both ways, because if you don't have a bi-flow, you can actually cause a restriction, and that can cause all kinds of problems. That's a common thing we do find with these. These are dryers, so they have two purposes. They filter out the refrigerant, but not only that, they're actually pulling moisture that they will find in the refrigerant. Moisture is a killer in a system. Any kind of moisture that is in these systems, especially with the oils that they use, they can actually form acid, and that's going to end up eating away at your compressor. It can do other things, but most of the time we see compressor failures because of that. This is a very simple part to put on every new install. These actually came in them factory. Some of them come outside. You'll see all kinds of different places where these will be. Like I said, some of them will be inside the unit. Others will be right on the outside of the unit. Some of them will actually be at the actual evaporator coil inside. So those are definitely things that you could look for to see if you have it or not. It's a good part to have on. Like I said, it's going to save that compressor. That's the whole point. We want to make sure we do everything we can to save that compressor. But it also does some things things with filtering different things so we don't have issues like restrictions and stuff like that. Good part to have when you're looking at replacing this. It is kind of pricey. You're looking at about $800 just to replace this. Obviously, if I have to get all new refrigerant, it's going to be a lot more. You're looking at more like $1,400, but this is a good part to have on it. It's great to see that they actually had it from the factory, because I can tell you a lot of times I don't see these installed, and they really need to be. So that's all I really have to say about this part. Let's go ahead and go over to the standard AC unit and see what it has, see if it has one on there. And as we see, we do have the same dryer, but this one is not a biflow. It's just one direction. So they always say them on there. They'll have a little arrow which way the flow of the refrigerant is supposed to go. There are times where guys put them in backwards, and that's going to cause problems. It's not a problem you might see right away, but let's say it got to be a really, really hot summer day, you might actually start seeing some restriction from this being backwards, or over time you could start seeing some things. So definitely want to make sure that these are professionally done. Anytime you're going to be messing with something like this, I would highly suggest that you get a professional for it, because you're going to have to deal with obviously brazing, you're going to have to deal with refrigerant, you need to make sure you're licensed for all that kind of stuff. As a homeowner, I would definitely have this done for you. This is not something that you have to do a whole lot. A lot of times I see these go for years and years and years, and I can tell you I've replaced a lot of systems that have the same dryer as it was the day it put in. That's a pretty good indication, because really every time you open up this system, you really need to replace this dryer. So it's kind of a telltale sign for sometimes us as techs. If the dryer's 10 years old and the system's 20 years old, something happened in between there. What happened? You know, was there a compressor that was changed out? Was the coil inside changed out? Somehow it was opened. What we see a lot of the times is guys don't replace these. So anytime you're having major components replaced, whether it be your indoor coil, condensing coil, outdoor coil, or your compressor, anytime we're opening up that refrigerant circuit, we really need to replace this. That's all I got to say about this part. All right, so next we got a service valve. Every unit should have a service valve on it. The only units that don't have service valves are usually kind of smaller refrigerations where they have very little charge in it. We have to usually tap into those kind of things. I can't think of any residential unit that doesn't have some way at least of servicing your unit. These come in handy. We have to have them from the very beginning so we can obviously pull vacuum, get all that moisture out of the system before we even start is the best way to start off. And this helps. This gives us a port to actually hook up and do all kinds of things. With that, this is a big failure point for the unit. We do see quite a few things happen here. One thing that can happen is these packings here can start to leak. That's why we always want to make sure we have a cap on this. That cap's going to save from that leaking. It's just another point that you can stop a failure. It's not a perfect one, but it does help. Same thing with the caps on these. We want to make sure that where we tie onto our service port, we have a cap on there. Without a cap, these little Schrader cores, they like to leak. They leak all the time. So if you put a cap on there, a lot of times if there's a little bit of a leak there, that will stop some. If it's a big leak, I'm not going to really be able to stop it, but I would highly suggest making sure caps are on this. Definitely check after your service techs leave. This is a common failure point for them to not put on caps. Hate to say it, it's the one thing we get all the time. I go to jobs all the time and somebody was out there a couple weeks ago and there's no caps on it, and you're going, come on guys. But that's one thing as a homeowner, I would definitely make sure if you're having any kind of maintenance done, go out there, just see if these caps are on. These are hard to see because it actually has a door that comes over the top of this, so you can't really see them. But for the most part, you can usually see this and see if these have their caps on. And then just making sure that they're tightened correctly, which is pretty simple. Most of them are the hand screw on. They just want them to be hand tight. If it's an actual wrench where it's like a 3/8 wrench, so you're going to actually want to take a wrench and give it about a 1/6 of a turn is usually enough torque to, past hand tight is usually enough torque to keep it sealed. With that being said, a Schrader core is the most common thing that fails on this. You're looking at about $150 for a Schrader core to be replaced. We obviously don't have to do any refrigerant for that. With that, you're probably going to be including adding refrigerant during that time, because if this is leaking, you're probably actually low on charge. These are sealed systems. Now, I will say no system is completely sealed, but they are sealed systems. You shouldn't lose any refrigerant out of it. If you are losing refrigerant out of it, you could be looking at a leak, and this is usually the first place I check. With that being said, since we're talking about refrigerant, let's talk about pricing on that, since it's the one component with both of these units you can't see, and I don't have a good way to show you unless I just bring a jug of it, is the refrigerant in here. Refrigerant is a big deal. We want to make sure no refrigerant is being lost from that unit. It is the killer of efficiency. So with that being said, our prices of refrigerant is actually really, really low compared to the national average. National average is about $200 a pound. We are at $100 a pound right now for 410A, which is amazing. So definitely think think about if you're going to use somebody for needing refrigerant, give us a call. But we do want to make sure we're looking for where that leak is. We don't really want to just add refrigerant and go on down the road. That's kind of the old practice, but that's not good for the environment. So we want to make sure that we're finding leaks and trying to get that thing sealed to where we're not putting anything into the environment we don't want to. With that being said, if you're going to replace this part, which is very unlikely, the amounts of these that I've actually replaced, I could count on maybe 1 or 2 hands. You know, it's not very often that you replace these, but when you do have to replace them, obviously we are going to have to pull all the refrigerant out of the system. Now, this is something we could recover the refrigerant and put it back in because it's not a major failure. It's not like a burnt out compressor or something like that, but we as a company, we like to, anytime we pull refrigerant out, just as safe precautions, we like to put new refrigerant in. So with this, whenever we do that, we're going to put new refrigerant in, and you're looking at about $1,500 just to replace this part. These do come with 2, one for your liquid line, one for your suction, and there's not too much difference. If we want to actually go over to the AC system, we can look at what it actually has on it. When we come to it, it's pretty much the same thing. No difference. You got your suction line and you got your liquid line. That's the only difference is this suction line is actually called 2 different things on a heat pump compared to here, but for the most part, you're going to have the same valve, no difference. And that's what I have to say about these parts. All right, next we're going to talk about pressure switches. Pressure switches come in all kinds of different varieties, but for the most part, they're there to protect the system in case of obviously sometimes low pressure or high pressure. This one actually here just has a high pressure switch. You will see that very common. Most systems are going to have some form of high pressure switch, because we obviously don't want that compressor pushing that pressure above. Some of these units can hit up to 500 psi when they're running them full load, but we want to make sure that we don't get any higher and that we cause any damage to the unit or hurt somebody. These are way too high pressures to be dealing with. We want to make sure everybody's safe. So that's one reason why manufacturers put high pressure switches. Now, manufacturers do different things on pressure switches. Like I said, there's all kinds of different ones. This one has opted to do a manual reset. So that means that if this thing goes off on high pressure, it's going to actually have a button that you have to push to reset it. And this one is actually found right here on the outside. Same with the other one. If the AC unit's going to have the same, but on this heat pump, it's going to have it right here. And so you as a homeowner could come out here if you had a problem and push that button just to see if it is a high pressure issue. I don't really suggest that. I suggest having somebody come out because you want them to look at why you're getting that high pressure issue. These do fail where they just don't read the right pressure anymore, but it's not as common as you would think. Usually you're going to have another problem, as a dirty coil would be a good example. Maybe you hadn't maintained your unit. This would be a good indication that you hadn't. In fact, if you come up to this and it's off on that, you push this button and it starts back up, I would be looking at your coil first thing and seeing if it's clean. If it's dirty, I would highly suggest go ahead and taking it apart correctly and cleaning it thoroughly. With that being said, these are common parts. We do replace them just because everything fails, and when you see thousands of units, you're going to see some of these fail. When we go to replace these, you're looking at about $325 just to replace this part. Can vary based on them. Obviously, this one I'd have to go to the manufacturer. It's going to take a little bit more because it actually welds in, so it's going to actually cost a little bit more because I'm going to have a lot more labor. I'm going to have to do things with the refrigerant, stuff like that. And this one, we might actually, if we had to replace this, what I'd actually probably do is abandon this, and I would tie into my high pressure side of my service valve and put one right there with the T so we can still access. That is the cheapest way to do it. It's a lot better than having to weld that in. Obviously, it's not factory that way, but you're looking at saving $1,000 compared to doing this as opposed to doing, a pressure switch that's more like this that screws on. With that being said, let's go ahead and look. This one didn't have a low pressure switch. Let's actually look at this AC unit and see what it has on it. So back to the AC part. These are your pressure switches on this. Obviously, this one does have your high pressure switch. It's going to go the same, and you're going to be able to have that where you reset it. This one also has what we call a low pressure switch. This is going to be great for if you got loss of refrigerant. It won't allow the unit to come on while it's in that low condition. This is a resettable one. So once the refrigerant fills back up, then you're good to go. It's pretty simple. You can also run into other problems to where you have other things that it's not low on refrigerant, but something's causing this. Maybe you have a dirty air filter inside, or let's say it's heating time and this little fuzzy dog right here is keeping your cooling in, and this is starting to ice up more and causing a low pressure. There's all kinds of scenarios why this might be. You could have a dirty coil inside, you could have a dirty filter not allowing airflow, and that's causing a low pressure issue, and that's going to cause this to trip. Once you alleviate that problem, change that filter, you could have a situation to where once that coil thaws, you could be back up and running, no problem, but it could be a bigger issue that you're actually low on refrigerant. So definitely check your filters. With that, very important part. Definitely make sure that if you're having any problems with this, I would definitely check your indoor coil, make sure you're getting enough airflow across there. Those are always things that can cause this, as opposed to just going that it's a refrigerant issue. But that's what I got to say about those parts. So before we move on to our next part, guys, if you like this content, make sure you're commenting below. Tell us what you do like, tell us what you don't like, tell us what you would like to see. With that, definitely make sure you're liking, subscribing. We want to make sure we're making all the homeowner content that's best for you. Now back over to our heat pump. This is another part we don't usually have on a standard AC. You do on the indoor unit, but you're going to have one on the outdoor and the indoor unit on these. Sometimes they don't come looking like this. Sometimes they're just a simple what we call a piston. That's what we used to use all the time, but a lot of manufacturers are moving to TXVs because they control your superheat a lot better, which can improve your efficiency. These are not very common parts to go out. I don't replace a whole lot of these on the outdoor. They are pretty great little TXVs. Usually when we're replacing TXVs, they're usually on the indoor. That could be a factor that we see more AC units and straight AC units than we do heat pumps. And then you're talking about a heat pump, you're gonna have an indoor TXV too. So it just might be a factor of how many we see, but not a part I really worry about too much. A lot of times when we see problems with this, what we actually see is like something will vibrate and actually break this hose right here, which ties into our suction line. So we want to make sure that that's tied in, and if it breaks off of that suction line, it's going to lose all its refrigerant. So I've seen quite a few where something rubs against this. Kind of normal things we see with copper. We want to make sure we're looking at whenever we're inspecting those units, making sure wires aren't rubbing on copper, making sure these copper lines aren't rubbing with each other, because it doesn't take very much vibration and it will actually eat a hole through this copper. So those are usually the things that I see go wrong with these on the outdoor, but they can do things by having restrictions. Different parts can fail. The sensing bulb can lose its refrigerant and then it can't meter like it's supposed to. But these are very important parts for a heat pump. Kind of gives us that ability to treat this as like it's the evaporator. Definitely don't want to be without it. When you're looking at pricing on this, you're looking at about $2,000 to change this, mostly because we're going to have to do some welding. That's going to always do it. We're going to be pulling the refrigerant out, and like I said before, we're going to be replacing that refrigerant. Most of the time we do not just keep that refrigerant in there. We want to try to make sure we're giving fresh refrigerant. We want to give the best scenario for the customer, and having good refrigerant in there is a very kind of inexpensive way to get that done. With that being said, that's really all I got to say about this part. If you look over at our AC unit, you can see there is no TXV. It just ties right into that coil. So again, this is a part that it could cost you some extra money. It's definitely a thing to consider, that you could have another failure. That's all I got to say about it. But it's not a part that I see you replace a whole bunch. I see a lot of these go through the life of the unit never needing this replaced. So it's probably something you kind of could consider, yeah, on the back burner, might have to replace it, but not very likely. Another part that's not on a regular AC unit but is on this heat pump is this reversing valve, also called a four-way valve. And the reason why it's called a four-way valve is because you have 1, 2, 3 pipes coming in, 4 pipes coming in. So with those 4 pipes, they call it a four-way valve. Reversing valve is kind of more the actual industry standard of it. You have an electrical part right here that's just a solenoid. That's going to be a factor. We do see those wear out and they might need to be replaced periodically. Not very common, but it does happen. The reversing valve itself, we have seen problems with them sticking. This is not a very common thing, but it does happen. And when they stick, we have to replace it. With that being said, a reversing valve is a very expensive part to replace. It's kind of like replacing any of the other parts where we have to open up that refrigerant line. You know, you're looking at replacing refrigerant, replacing the part. With this, you're actually looking at more of like a $2,500 to replace it. That is going to be kind of specific for the brand, so I might be able to get a little bit cheaper, but yeah, that's pretty close to what you're going to do. You do have a Schrader core on this. That is a failure point. You know, like we talked before, that's about $150 to change it. They do leak, but as you saw, this does have a cap on it, and this is actually like I talked about earlier, this is a screw-on cap. You just hand screw it on. Nothing special. I don't have to get a tool on it or anything, just hand tight, and it's usually pretty good. And the reason why they do that is because there's an actual O-ring in it, and that helps seal that part. But yeah, for the most part, these don't really go out too much. I've replaced quite a few of these, but it was a manufacturer error. They were all the same units. I've replaced a lot of reversing valves because of that. The likelihood that you would have that unit is highly unlikely. Great part. It's going to reverse that flow of the refrigerant. That way we can get the efficiency of having it run in heat and running in cool. We want to make sure we're getting that extra efficiency we can from not having to run heat strips or even gas. If you believe it or not, sometimes gas is not the most efficient way to heat a home. So when we go to talking about heat pump, this part is the part that makes this a heat pump. Out of all the other parts that we've had, yes, they're necessary, but this is what is kind of the gold standard. This, if you see one of these in there, it's a heat pump. That's how you tell the difference, is this reversing valve. That's what's going to let you know. A very important part. It's going to allow us to do that where we can have this operating in the heating season or operating in the cooling season, saving that money all year long. I would highly suggest a heat pump. And with that being said, let's go. Before we go to one more part, I'll talk about this. Heat pumps are great units. You've heard us talk a lot about the negatives of heat pumps, but I would say the positive of heat pumps is how much money you save. If you actually go and do the math on a standard AC unit versus a heat pump, even if you have a gas furnace, you have electric furnace, I don't care what kind of other heat source you have with it, a heat pump is going to do better. And by all means, argue in the comments below. I can show you the math. That's what I'm going to go off of. There's some negative things about a heat pump. I like heat pumps. My next house will be a heat pump because I'm going to do total electric. But with that being said, even if I had gas, I'd still go with a heat pump because the amount of money you have to pay extra is not that much when it comes down to the savings that you'll gain over the life of that unit. You're looking at spending about $1,500 more for a heat pump on average. And so we're looking at $1,500 more is not that much when you consider how much every year you're going to save on your heating bills. Obviously, if you go with a gas furnace, you're not going to save quite as much. If you go with an electric air handler, definitely going to save all day long. I would suggest it. Now, the negative things that I would say with a heat pump, which they're getting a lot better. Manufacturers have stepped up their game tremendously on heat pumps. They're more efficient, better than ever. But the negative things I would say back in the day is a lot of the people had problems with heat pumps is they don't like the air that comes out. I get a lot of customers that you put in a heat pump and they go, that air feels pretty cold. Well, that's another problem. What really happens is your skin's about 98 degrees. So if you have air blowing on your skin that's anything below 98 degrees, it's gonna kind of feel cooler to you. It's not gonna feel like that gas heat, especially gas heat's great for having that blowing hot air. You're looking at about 120 degree air coming out of your vents from a gas furnace, to whereas this is probably gonna do anywhere from 95 to 105. So that does factor in things that you wanna consider. And is that a consideration that you don't want a heat pump because it blows air on you? I think we can actually alleviate the air blowing on you is probably a better way to do it than just not having the heat pump. And that's a lot of the complaints in a real ideal world of HVAC. I don't want air blowing on you as a customer. I want you to feel comfortable in your home and not have air blowing on you. I used to have a seat at my old house where we got new windows, and I knew we got new windows because now I could feel my air conditioning blowing directly on me. And so it was not comfortable. So ended up changing a grill out. You can do simple things like that just to make it more comfortable for you as a homeowner, as opposed to spending more money, all that kind of good stuff. Heat pumps are great. I like them a lot. Used to not like them because I didn't understand the technology. The more I understand the technology, the more and more I like heat pumps. All right, so next component we're looking at with this system, the heat pump, is your compressor. This big boy right here. Part of the system, very important. You're going to find the same thing on every AC unit out there right now. I can't think of one that doesn't have a compressor. They all have different kinds of compressors. This one right here is what we call a scroll compressor. Very common nowadays. In fact, I would say that 70% of all units put in today have a scroll compressor. We are moving away from the scroll compressor to a rotary compressor. They're very similar and they function close to the same. I will say there is a lot of benefits for the rotary compressor, and I'm kind of glad to see they're going that way. But these were great units while they lasted. Definitely had a lot of upgrades from the old reciprocating compressors. There's some benefits with the reciprocating compressors. They're almost bulletproof, but they did have failure points, and obviously any of them are very expensive to replace any kind of compressor you have. You look at something like this, a 2004 unit, and you're looking at replacing that compressor, you're looking at about $4,000 to replace that compressor. Could be more. Obviously, I'm going to have to price that out with the manufacturer, but if you're under warranty, and usually most units come with a 10-year warranty nowadays, you're looking at somewhere around $2,000 to replace that compressor under warranty. Now, that is very expensive, and that's why anytime you get to a unit that's obviously 22 years old, or anytime you get a unit that's really outside of the warranty, you need to start considering what's the cost of a new unit, and at least know what that cost is. That might not meet your budget. We can replace a compressor and get you going down the road and get you to that next point to where we can look at replacing it later. We're always willing to have that option. Just putting $4,000 is not something that we really suggest for a customer, but everybody's different. We want to make sure we accommodate for everybody. And it's something that definitely, if you had a really, really great unit, you know, maybe you took care of it really nice and never really had anything and it just failed at 10 years, we're right past that warranty, it might be worth it to put it to try to get you another 10 years out of it. Those are always considerations to do. But if we move over to the AC side, I think you're going to see it's almost identical. The only difference in this is that compressor is a little bit smaller, so I don't have to break my back as much if I have to lift it. There's not really anything different with it, minus got a little bit more dirt. They're both R22 systems, so we know that they are almost identical. I wish I could tell you the difference in the motors, but actually you can't actually tell too much on them. I'd have to actually look up the spec sheets on them. Overall, if you're looking at replacing some of these big items, I always used to say if you're going to put 10% of what the cost of a new unit is, it's highly suggested to look into going ahead and replacing if it fits in your budget. I will say that we have financing now that is amazing. Definitely want to look into that. I do believe they have options for 0% financing. We can also do that on parts now. Anything over $1,000, we can look at doing some financing on that to try to make it better for you as a customer, to make sure you're getting what you need, that you're getting that comfort that you want. So here we are. We've actually looked at the heat pump. We've looked at the AC unit, went part by part, side by side, seeing what the differences were. As we saw, it was only a matter of a few parts that were actually different in this system. So when you're looking at a heat pump, the average size is about 3.5 ton. When you're looking at that cost, you're looking at somewhere around $12,000. When you're looking at the AC unit and you're looking at cost, like I said, for a 3.5 ton, you're actually looking at more like $10,500 on average. So those are definitely price differences in both of these. Obviously, we do have a couple more parts on it. There's a little bit more technology with the heat pump, so that is going to factor into how it's done. They're going to put a couple more things. Usually manufacturers usually like to make their heat pumps a little bit better built, because they are going to have to obviously run in different scenarios, as opposed to just running in the summertime, hot weather. You're going to have to be running in the hot and the cold. So the manufacturers like to try to make sure their stuff's going to last. So there you have it. It's about $1,500 difference. Tell us, what kind of decision are you going to make? Guys, I'm Keith with Yarbrough Sons. I'll see you in the next one.
Yarbrough Sons, Yarbrough Sons, these are the folks you should know. No need to sweat, no need to fret, call 485-3470.